Hello class, in this video I'll be doing the fifth example on how to find the limit of a function given its equation. Let's begin. Find the limit by multiplying by a conjugate. And before you can find the limit, you have to determine if the limit actually exists. So I've already gone ahead and substituted 0 in for h and got the indeterminate form 0 divided by 0. But please note, since the value of x is not given, the limit will be a function of x, not a number. So when we're all said and done, the limit is going to be some function of x. And to find that limit, we have to multiply by a conjugate. And I've already gone ahead and provided the conjugate for the square root of x plus h minus the square root of x. And that is the square root of x plus h plus the square root of x. So let's find the limit. I'm going to multiply the numerator and the denominator by the square root of x plus h plus the square root of x. And then I'm going to apply the property a minus b times a plus b is equal to a squared minus b squared. I'm going to apply this property to the numerator. So this is the limit as h approaches 0 of the square root of x plus h squared minus the square root of x squared divided by h times the square root of x plus h plus the square root of x. And again, I did not distribute the h in the denominator because we may be able to divide like terms here after simplifying the numerator. Let's go ahead and simplify the numerator. So this is the limit as h approaches 0 of x plus h minus x divided by the denominator, h times the square root of x plus h plus the square root of x. X minus x is 0. So in the numerator, we're just left with h. And the denominator does not change. Now, if you look, there's an h in the numerator, and there's an h in the denominator that divide. And the result is 1. So this is the limit as h approaches 0 of 1 divided by the square root of x plus h plus the square root of x. And from here, notice that if we substitute 0 in for h, we no longer get 0 divided by 0. We actually get an expression. So this becomes 1 divided by the square root of x plus 0 plus the square root of x, which is 1 divided by the square root of x plus the square root of x, which equals 1 divided by 2 times the square root of x. So the limit as h approaches 0 of the square root of x plus h minus the square root of x divided by h is equal to 1 divided by 2 times the square root of x, provided that x doesn't equal 0. Because if x is equal to 0, then 1 divided by 2 times the square root of x is undefined.